Good afternoon, everyone. I'm so happy to welcome you to this edition of the Faculty Insights presentation. I'm Bill Sanders, William D. and Nancy W. Dean of the College of Engineering. In fall 2020, in the midst of the pandemic, the College of Engineering kicked off a new webinar series entitled Faculty Insights, a 20-minute briefing, which we're holding 5 times per year. In this virtual series, faculty from across the College of Engineering will share insights into their research, its impact, and a perspective for the future. Following each 20-minute presentation, attendees will have an opportunity to direct questions and comments to the speakers. Our speakers today are Valerie Karplus and Daniel Tkacik. They will be presenting on decarb at CMU. The mission of decarb at CMU is to engage campus faculty, staff, and students in research, education, and outreach to advance deep reductions in the greenhouse gas emissions from the industrial sector, while growing opportunity and well-being for workers and communities in Southwestern Pennsylvania and the Tri-State Appalachian region and beyond. Valerie is an associate professor of engineering and public policy with a courtesy appointment in the Heinz College here at Carnegie Mellon. She studies resource and environmental management and organizations in diverse national and industry contexts, with a focus on the role of institution and management practices in explaining performance. Valerie's areas of expertise include decarbonization of global corporate and industrial supply chains, regional approaches to low carbon transition, and the integrated design and evaluation of energy, air quality, and climate policies. She's previously worked in the development policy section of the German Federal Foreign Office in Berlin, Germany, as a Robert Bosch Foundation Fellow, and in the biotechnology industry in Beijing, China, as a Luce Scholar. From 2011 to 2016, she co-founded and directed the MIT Tsinghua China Energy and Climate Project, a 5-year research effort focused on analyzing the design of energy and climate change policy in China and its domestic and global impacts. Valerie holds a bachelor's in biochemistry and political science from Yale University and a PhD in engineering systems from MIT. She also previously served on the faculty of the MIT Sloan School of Management. Daniel is the executive director of the Wilton E. Scott Institute for Energy Innovation. He has been at CMU since 2009, having earned a master's and PhD in CMU's Department of Civil and Environmental Engineering. As a National Science Foundation Graduate Research Fellow, Daniel researched air pollution from combustion systems and helped advance the understanding of secondary organic aerosols. From 2013 to 2014, he served as a postdoc researcher, traveling around the United States, measuring methane emissions from national gas facilities to better understand the impact of greenhouse gas emissions from the natural gas sector. Valerie and Daniel, thank you for being here today to talk about the Decarb at CMU initiative. Before I turn things over to them, please know that you can submit any questions you have via the question and answer feature at the bottom of your screen. You can do this at any time during the program, and please ensure to include your name with your question. After the presentation, Gina Henry, Associate Dean for Advancement for the College of Engineering, will be moderating the question and answer session with Valerie and Daniel at the conclusion of their presentation. So I'll turn it over to our speakers, and thank you very much.
Thank you so much for that great introduction. Thank you really to everyone attending this webinar. It's really great to see so much interest. Today, Valerie and I will be spending a few minutes sharing a new initiative at the university that's got a lot of energy behind it, which we're dubbing Decarb at CMU, and how people policy, technology, and systems can enable a low carbon transition in industry. And as Dean Sanders said, I'm Daniel Tkacik. I'm the Executive Director of the Scott Institute for Energy Innovation here at CMU. And in a few minutes, you're going to hear from my colleague, Valerie Karplus, the Strategic Advisor to the Dean for Decarbonization and an Associate Professor in the Engineering and Public Policy Department. So this initiative really stems from the fact that decarbonizing energy use is absolutely vital to achieve our climate goals. So you can see in this Sankey diagram that the vast majority of greenhouse gas emissions come from energy use, whether it be electricity and heat in the very top left portion of that graph, down to buildings, manufacturing and construction, transportation, and fugitive emissions, which I studied in my postdoc, as Dean Sanders said. And we can see this in the middle of the graph labeled end use and activity, but the energy the energy is being used for everything that powers our lives and our economy. So our houses, our places of work, the steel for our cars and our bikes, and the concrete for our roads and buildings, and so on and so forth. And so we're heading in the wrong direction. Last year, global greenhouse gas emissions increased for the second year in a row. Emissions decreased in 2020 because of the global pandemic. So changing the direction of the emissions trend will require more than just cutting edge technology. It's going to require significant investments in infrastructure, making sure the workforce and communities aren't adversely affected by an energy transition, and of course, policies. So our answer is this new initiative, Decarb at CMU. Decarb at CMU is the university's stake in the ground that we are focusing on our efforts towards decarbonizing our energy future. And since decarbonization is such a broad term and sometimes a hard word to say, the energy world is vast, and so we're starting with the industrial sector. We already have a lot of existing efforts within the Scott Institute focused on decarbonizing, and we'll get to those in just a few minutes. But what we're lacking right now is really a unified identity around all of them. And that's exactly what Decarb at CMU will help do through strategic and internal and external tactics to raise awareness. Decarb at CMU will galvanize internal and external constituents to both further support CMU's efforts in decarbonizing, as well as forge new ones. And this is all happening as we've seen monumental pieces of legislation that will create huge opportunities for working towards deep decarbonization. So the initiative really aims to set itself up to go after sustainable sources of funding. So shifting into high gear, this is kind of where we talk about kind of the four thematic areas. And these are really important, what we're kind of positioning the entire initiative around. So first, we have technologies and systems. So how do we evolve or replace existing technologies and processes so they don't emit high amounts of greenhouse gases? Secondly, we have how to design, cite, and incentivize the ongoing use of clean power, direct air capture, carbon sequestration, and hydrogen. So we're kind of referring to these as these enabling infrastructures. And going back to the first pillar, like once we develop these technologies and processes, they're kind of meaningless if we don't have the right incentives and the right enabling infrastructures to actually put them into place. Next, we have organizations, institutions, and policies. So what decisions do we need to make to encourage action to deploy decarbonizing solutions? And then last, we have community and labor force. So this is a huge topic that everyone is for good reason concerned about. How do we make sure that worker and community impacts are not adversely affected? How do we expand opportunity? How do we improve public understanding and acceptance? Because if we don't have public acceptance of this, it's just not going to work. So here, I'm going to pass things off to my colleague, Valerie.
Terrific. Thanks, Daniel, and thanks, Bill, for the introduction. So as Daniel mentioned, this is really about addressing all the different components of the recipe, so to speak, to enable a deep decarbonization of energy and economic systems. And by focusing first on the industrial sector, we're really leveraging a couple of key strengths at CMU. In particular, the work of the Center for Iron and Steelmaking Research and some of the energy systems work, techno-economic analysis, as well as life cycle assessment. All of that comes together to think about the challenge of decarbonizing the steel industry. There are a number of emerging options on the table, some of them more near term in the form of natural gas-based direct reduced iron production. We're looking at the next generation hydrogen-based DRI production, as well as collaborating on some of the more frontier alternatives for decarbonizing iron making and steel making as well. Then in the realm of carbon capture and sequestration, this is connected directly to the infrastructures pillar. We're really focusing on characterizing sort of from the basic science, the membranes, the structures, the best morphologies that can take from the exhaust gas streams of these plants and extract the CO2 effectively, compress it in an energy efficient way, while still removing local pollutants at the same time, and then piping and storing or sequestering that permanently under the ground in deep geologic formations. And so this is a very important and has long been a very challenging and economically particularly challenging area for these applications. But we are seeing in the new legislation a lot of focus on enabling these technologies through both the large funding programs, the DOE Earthshot and some of the basic science programs, as well as the tax credits associated with capturing and storing CO2, such as 45Q. Now, in the sort of in the labor area, which Daniel mentioned again, another very important ingredient, the labor and community impacts of clean energy transition really draw on the strengths of some of our faculty, both in the Heinz College as well as in engineering, to understand both the skill sets that are going to be needed, but also think about what the workers will require in terms of salaries, in terms of benefits packages, in terms of location, in terms of enabling infrastructure for labor in particular. So we can think of daycare, other services that are complementary with building a competitive labor force, particularly in our region here in Southwest Pennsylvania and in the Tri-State Ohio, West Virginia area. Now, in the AI and machine learning area, we have a number of faculty who are doing extremely exciting work. I've listed just a couple of them here, and that's true under each one of these headlines. I leave these names here so that you can go and look them up, get excited about their work, and then come let us know what types of projects excite you. But I think we could all agree that CMU has strengths in particular in sort of the details and depth of these areas, but also in bringing together across all four pillars the interdisciplinary expertise to really bring these transformative breakthroughs on the technology and engineering side into industrial practice. So next slide, please. And I want to emphasize that this is very much in many ways contributing and benefiting from the region where we are here in Appalachia, but it is also connecting with and growing globally. So we have an initial partnership called INDABA. This is the Industrial Decarbonization Analysis Benchmarking and Action Partnership, funded by an NSF grant under the heading Partnerships for International Research and Education. So this is an early seed of an effort we would like to grow. An early focus of this work is on decarbonizing the global iron and steel industry, and we welcome inquiries and partnerships that will help to advance some of these objectives. In a nutshell, what we're basically doing is we're using a combination of engineering and data science, techno-economic analysis techniques to understand where the geography of future low carbon steelmaking is likely to be and which technologies are likely to be most cost effective under alternative policy scenarios. So you can ask the question, well, should we locate decarbonized infrastructure in the places where we might displace fossil energy production and use today? And I think it's an open question, but we're going to run different simulations that consider different factors and try to understand how this global geography will evolve in a way that can usefully inform policymaking that considers multiple objectives. Next slide. So this initiative is now really taking shape within the faculty and across the campus. So we've surveyed the Scott Institute faculty affiliates, so really across all of our schools, faculty who have an interest in energy, and collected their various decarbonization related expertise and interests across decarb at CMU. And we've built out an experts list, and this list keeps growing, which is always a good sign as we get particularly more of our science and engineering faculty who say, hey, actually, what I do is kind of similar to what that problem needs, or the breakthrough that I have could potentially be repurposed for this application. We've also, and sort of to foster this community internally, we've held community lunches, and actually this slide should include our most recent one, which really brought together not just the researchers, but also gave them an opportunity to share their work in decarbonization. We have a preliminary white paper, which we're happy to share with anyone who's interested. And we're in the process of grouping faculty by sort of keywords, if you like, to respond to a broad range of new federal funding opportunities. At the federal level, much of the interest and opportunity comes from the National Science Foundation, as well as the Department of Energy. We're seeing funding opportunities on a scale we haven't seen since the post-war era, post-World War II. And so I think this is really a pretty exciting time to be working in kind of across the spectrum from fundamental science to industrial scaling of these clean energy technologies. We are looking at forming a close-knit corporate partnership to help refine the use cases, and also to support and engage with our researchers in solving problems that are fundamentally of interest to the companies, as well as to fundamental science and engineering, so pre-commercial research. And foundations have already been incredible in stepping up and supporting us as we embark on this journey. I should say that decarb at CMU is less than a year old, and it's growing organically from within, and it will continue to I think, benefit from its distributed strengths and the network that it's creating across the university, and we hope with its alumni community as well. Next slide. So we're starting with some key contributions from government, foundation, and industry sources. These different sources are just a starting point for us. We are also looking at a number of the new funding opportunity announcements and have applied for several as well. We are also working with partners in the region to go for an NSF engine, which this is the new series of grants that have been announced through the Technology Innovation and Partnerships Office. And I think you will hear a lot more about the exciting not just the opportunities, but those we managed to land and incorporate into the sort of growing portfolio of decarbonization related activities around the campus. Next slide. And I should, I think just to sort of put a fine point on it. So looking forward, we have this deep engagement on the Regional Clean Hydrogen Hubs team in Pennsylvania, the Carbon Capture Demonstration Project, which is led by the Allegheny Conference and Community Development, essentially Pittsburgh's and the region, 10-county region of Southwest Pennsylvania's Chamber of Commerce. The NSF Engines I mentioned is led by West Virginia University, but supported deeply by commitments from Pitt and from our neighbors at University of Pittsburgh, as well as Carnegie Mellon. We are the lead on one of the multi-topic industrial decarbonization offices opportunities, and we are planning several more. So we feel like this is a very strong foundation, both to continue to have impact in the research that we can grow from within, but then also to work with our partner universities in the region to realize synergies and to create a broader ecosystem that will enable entrepreneurship and transformation. And honestly, I think you can imagine our region is really well poised to be an energy entrepreneurship hub. West Virginia is already third in the nation in terms of atmosphere for startups and venture capital in this space, as well as in other areas. And so this is a tremendously exciting time to be working on these topics. Next. So I think we think about sort of the elements of a successful initiative. So what does this look like at scale? And we see this as really catalyzing faculty teams to engage in grand challenge research. We're already starting with low carbon iron and steel making and carbon capture and storage, as well as thinking deeply about the workforce community and diversity, equity, inclusion, and accessibility impacts of the energy transition. We hope to publish and share working papers with all of you, including work on a techno-economic analysis of these low carbon pathways, understanding how to better match existing workforce skills and potential workforce skills with the needs that are coming along, and figuring out how to do community engagement well. I can, I can't count on my two hands the number of groups that have come and said, how do you write a community benefits plan? How do we engage with these new federal funding opportunities given the emphasis on community and labor? And so that I think is something where we can further develop and assemble a collection of best practices and expertise, but also write about that and be a catalyst for a broader use of those practices. Finally, I think it's important to mention the regional dialogue again. I've been in West Virginia for at least 24 out of the last 48 hours, having made two separate trips, one to Wheeling and one down to Morgantown this morning. And these dialogues on regional energy coordination, energy infrastructure deployment, funding opportunities are really, really exciting. And I think you'll be hearing a lot more about this in the years to come. Finally, we're very interested in putting together a group of founding sponsors. So this is ideally a small group of companies that is committed to the energy grand challenge of deep decarbonization in industry and largely in steel, cement, and chemicals. It's sort of our early focus, and industrial carbon capture is part of that, but obviously you can't leave out the infrastructures. All of those four pillars that Daniel mentioned are central to what we're trying to develop. And then longer term, we're looking at opportunities to develop this into an NSF or DOE funded initiative that crosses all of the departments on campus and continues to build momentum on and be nimble and responsive to the needs of the country as decarbonization moves forward. With that, I think, Daniel, is it back to you for Energy Week? Is that right?
Yes. Yeah, so Energy Week took place just a week and a half ago, and we focused the programming mostly on industrial decarbonization. And it's a particularly interesting topic globally, of course, but especially in this region, as Valerie just talked about. And all the keynotes were focused on the four pillars of decarb at CMU. So we had a panel on technologies and systems, enabling infrastructures, policies and institutions, and workforce and communities. And really going back to what Valerie was talking about with building community action plans, like there was so much enthusiasm around the panel on workforce and communities. I would say that had the most chatter, and it was just a really good opportunity for representatives of workers in the region and globally. We had someone from DOE Office of Clean Energy Jobs there to really have an honest conversation about this. And I really think it was a good starting point for these conversations. And so, and apart from the great productive conversations that we had as part of the programming, it really did just serve as a proof point for interest and enthusiasm around this topic. So we're really, really excited to continue and build out this initiative. And for any of you who were in attendance, that was great. But if you were not there and you want to, see how things went, most of Energy Week will be on YouTube in a few weeks, and we can share those links to those who are interested. So again, really, the Energy Week a week and a half ago was really just to get all the troops together in the region and nationally, and to really start this conversation, really serve as a lightning rod to bring people to talk about this really challenging topic. And again, as a conversation starter, we plan to work with many of the industries that were present for the week. So it was a good piece of of our development of decarb at CMU. So with that, I understand we want to have lots of time for questions. So we are at the end here, and we will be happy to take your questions.
Daniel and Valerie, both, thank you very, very much for such a great presentation today. This was very informative, and we very much appreciate it. As Bill mentioned in his introduction, my name is Gina Henry. I'm the Associate Dean for Advancement for the College of Engineering, and I will be helping Valerie and Daniel by moderating the Q&A session this afternoon. So first of all, if you're just joining us, thank you very much for joining us. You will see that at the bottom of your screen, there should be a Q&A button where you can click and submit your questions. So if you do have questions for Valerie or Daniel, please submit those and we will be answering those, as many of those as we can during this session. So first off, we had a question submitted that I'm going to read just so that I get it in its entirety. And this question was the first one that came in being submitted. And the question asker says, while I agree with reducing carbon, I find many of the solutions don't make good sense. For example, it's not entirely clear that the carbon footprint of electric vehicles is all that much different from gas-powered vehicles, all things considered, including the energy to charge the cars and the adverse effects of mining rare minerals. I'm concerned that we put a stranglehold on the US economy and security while looking the other way on the real polluters in India and China. I'd like to see a strategy based on the concept of return on energy quality. The concept is a more balanced approach where REQ takes into consideration not only the environment, but also energy independence and national security, health and safety, the economy and jobs, and sustainability. If CMU were to adopt REQ, it could have a tremendous impact on the national agenda and carve out a leading edge role for CMU. So that was a bit of a long question, but Valerie and Daniel, I think you get the sense of it. Can you respond?
Sure. Yeah, I think this is really important, right? Because we are facing multiple objectives. And when we talk about decarbonization, we're saying we want to continue to do things as we're doing them, or grow our economies, develop our societies, our lives in directions without that carbon footprint. So we need to be 100% clear that the solutions are reducing carbon emissions. You gave the example of electric vehicles, and it's true in some parts of the country, not all parts, but in places where you have a lot of coal as the marginal generation source, you do have a higher carbon footprint for an electric vehicle that is run on coal compared to a brand new off-grid hybrid vehicle. So a vehicle you're not plugging in, but it has electrification in the powertrain, or a very efficient, maybe if you want to, again, I think we need to be clear that we're looking at vehicles with similar functionality. You can find some very efficient internal combustion engine vehicles that compare. However, I think in places where we have low carbon sources, we need to recognize the potential that electric vehicles have to reduce carbon emissions. Similarly, we need to be thinking about getting coal out of our energy systems broadly, or finding ways to abate the carbon associated with those systems. I think your suggestion was an REQ metric, but there are many different ways you can measure these multiple objectives. So we do consider them very strongly. It's sort of built into the structure of the program. Actually, if you think about jobs and communities and policy objectives and institution building as being part and parcel of what we're trying to do in advancing decarbonized technologies and infrastructure solutions, it's obviously the devil is very much in the details. And so that's where these different metrics can really, multi-dimensional metrics can help hold us accountable. So we are very very, very interested in the jobs impacts and the community impacts, the air quality benefits, for example, that come from undertaking some of these decarbonization investments. And so I think what we're hoping is that we'll also provide that thought leadership to those policymakers who are evaluating some of the applications to some of these programs and help them understand how they can take into account these multiple objectives. And obviously you want it to be affordable as well, because otherwise you get economic dislocation and other undesirable outcomes. And so I should use this moment to actually plug another initiative within the engineering school, which is the National Network on Critical Technologies. And this focuses more directly on your question about rare earths, but of course that is related, or about critical minerals in general, which is related to your question about the resource impacts and associated impacts on our economy of mining, refining, and building electric vehicle batteries in this country. I think that project has quite a bit to say about those issues and is very connected with the decarb initiative in terms of thinking about the implications for clean energy. Great question, thank you.
Thank you, Valerie. Appreciate that, and thank you to the person who asked that question. Next up, could renewable electricity be used instead of natural gas in cement manufacturing?
So, Daniel, did you want to take this, or?
I mean, I'll say a few things and then you can take over, because so I am aware that there are companies out there, startup companies, one of which out of CMU is looking at using different chemical processes to create cement. And there is a lot of electricity that is being used to create cement, and you could definitely supplement a lot of the energy needed to create that cement using renewable energy. Cement is one of the bigger sectors or subsectors of the industrial sector that emits, and using renewable energy to supplement the energy needed to decarbonizing to create cement is definitely something that is being considered, as well as looking at the chemistry and the various chemical processes that is sort of what we call the process emissions, just simply the chemistry that is happening that creates CO2 when you're removing, you're purifying the limestone to create the cement. So I just wanted to share that, yes, renewable energy could absolutely be used in cement making, but there are also other things that are being considered. Valerie, I don't know if you want to add anything else to that.
Great. Yeah, I think you're right to point out that a lot of this research is underway at CMU. Many of these technologies are pre-commercial. The one that I would highlight is actually a kind of an analog in iron and steel. So there are efforts now to try to convert what's now the blast furnace process for taking iron ore and reducing that to make iron to feed into the downstream processes today. It's a basic oxygen furnace. That integrated steelmaking route, it is very carbon intensive. In fact, it's the blast furnace itself, that reduction step is responsible for most of the CO2. And so by replacing that step with an electrolysis process, which basically, so this is something that CMU is actively collaborating on, is thinking about taking that process and then this is obviously something that's, I think broadly important in the space. You've got a lot of low-grade iron ore out there that you can take and convert to using the electrolysis pathway, and the sort of innovative hope is that you could do this with renewable energy in a way that is responsive and at much lower temperatures. You think about the temperature of a blast furnace, 4 digits, 2000 Celsius. We're talking about a temperature of 60 degrees Celsius, so roughly the temperature of your cup of morning coffee. And so that type of sorry, I don't know what happened. That type of process can be converted to the blast furnace process today uses a lot of coke, a lot of direct fossil energy use that could be potentially electrified very much pre-commercial, but has a number of other attractive attributes. And so I think we need to think broadly and creatively. I should say it also creates byproducts that may be useful in cement making, right? So there are these kinds of interesting connections across the technology pathways that CMU researchers, as well as I think the broader community, are working to understand.
Thank you both. Our next question goes away from the technical and more towards the structural. How is decarb at CMU different from what the Scott Institute was set up to be?
Sure. So that's a good question. So decarb at CMU is kind of taking a finer point on a very specific, area, if you will. So you could really draw a crazy Venn diagram of how all of the different things that the Scott Institute are working on related to decarbonization. But the point of decarb at CMU is to really put very intentional effort to bringing people together to work on these very specific areas. So while it's sort of like I talked about in the first or second slide, that decarb at CMU is really taking a lot of the existing activities that's already happening at CMU and making sure that these folks who are working in these areas are meeting each other and talking to each other. And like Valerie said, we've been holding these lunches, and it's just sort of astonishing the number of times that people are like, oh, hey, I didn't know you were working on this. We should talk. And it's like, that's exactly what this initiative is really about, is getting people together in a room focused on a more, a sort of a unifying effort, which is decarbonization. And there are many pieces of that, whether it's the workforce, whether it's enabling infrastructures, rather than just kind of energy innovation at large. And so previous to decarb at CMU, that's what the Scott Institute has done, is it's sort of gone out and looked at who's working on energy, who's working on advancing energies, who's working on efficiency, who's working on batteries, storage. I mean, I can go through the whole laundry list. And that's been effective, but given these climate goals that we're seeing, that all of these, Fortune 500 companies and others that are putting out there saying they need to decarbonize by X date, and they don't know how they're going to get there, that's what really motivated us to say, okay, well, we need to figure out, what is the DOE saying that their roadmap is? What do we have going on here at CMU? Who hasn't met each other yet? And one could argue that the Scott Institute wasn't doing its job. And if you bring people together and they are meeting each other for the first time, sure, but we've never really gone after this, more focused effort before. And so the fact, like I said, the fact that we're bringing people together and many of them are finding new connections at the university that they didn't have before, around a slightly more refined topic other than just energy innovation at large, tells us that it's working. And so that's kind of how the initiative kind of is a bit different from what the Scott Institute has done in the past. So long story short, just a more refined look at a specific topic. Valerie, if you want to add anything, feel free.
I think that's great. I mean, I would say you could think about it like decarb at CMU is software that runs on the Scott Institute hardware. The Scott Institute is really enabling this initiative to grow and fly. And I hope, I think over time, there may be other initiatives related to energy that come out of the Scott Institute in the same way. And so Daniel is here because decarb at CMU is connected with and being sort of born out of the Scott Institute.
Thank you. I think that was a really good sort of encapsulation of how decarb at CMU is really an initiative of the Scott Institute. So thank you for that very good answer. Okay, next question. What is being done in development of a liquid synthetic fuel from water, renewable electricity, and CO2 to be used as a fuel for diesel and turbine engines, thereby reducing oil consumption?
So I think, this has not been a direct focus of the decarb initiative yet. I think it's really important that we find synthetic drop-in fuel substitutes, low carbon options for the transportation sector in particular. Hydrogen may play a role. Electrification is definitely sort of expected to be part of the solution for light duty vehicles. So in some ways, this is this conversation has been going on for a long time. But in terms of sort of the early focus of decarb at CMU, that's not something we're going to be tackling directly, but we're going to be looking for opportunities to get involved over time.
Great, thank you. Let's see, the next question on our list has to do with legislation. What do you think needs to be done for more climate legislation to be passed in Congress?
So I can give my glass half full answer, Daniel, if that's all right. So I think one of the biggest risks that we face right now with all of these new pieces of legislation is that we come up empty-handed at the end of it, that we squander this opportunity. And in many ways, that you see the rapid pace of deployment of these funds. There seems to be a deadline every second week for different opportunities. People are scrambling to get material and teams and community benefits plans together. And so I think to get more climate legislation passed by Congress, there need to be some early wins based on what we have so far. And that, I think, some of the projects that CMU is now involved in, I think there's a lot of promise. We need to be focused. We can't boil the ocean. We're already doing that well enough on our own. Climate change isn't getting, isn't slowing down, right? So I think one of the things that, the other thing that's going to be important, and this goes back to the first question, where the asker had mentioned global action in India and China and elsewhere. I think we're going to start seeing a lot more activity globally in terms of investments in clean energy. We have already a carbon price in Europe. If companies, and I think many are starting to see what the path looks like, they may be willing to sign up to a carbon price or some form of, a way of incentivizing in a technology neutral way, things that bring emissions, greenhouse gas emissions down. And so I think, once we have a little bit more clarity on what the path looks like, I think there's going to be more confidence as well in making some of these bolder policy moves.
Great, thank you. The next question comes from a brigadier general who is joining us here. The Air Force creates approximately 45% of the GHG emissions for the federal government due to aviation training and missions. Is decarb at CMU looking at sustainable fuels for aviation and vehicles?
It's not currently a focus, but it is certainly we have folks in the Scott Institute who are focusing on transportation and alternative fuels, because at the moment we're really sharpening our focus from a very broad topic of decarbonization to industrial decarbonization. We don't plan to do that in the very near term, but the way that we see decarb at CMU moving forward and long term is we start with the industrial sector. Then we look at, amongst all the faculty who have, signed up to be part of decarb at CMU. And as Valerie said, that list is growing. Maybe next time we see that we have a very growing number of people working on transportation and alternative fuels for aviation, and that could certainly be a focus in the future. But at least at the moment, we are not focusing specifically on that.
And Daniel, thank you. Oh, sorry, Valerie.
And to add very quickly, just to what Daniel said, I think we're also trying to figure out what the best niche is to start from. So there is so much good work going on alternative aviation fuels, and I'm happy to share work and studies and collaborators and other institutions. I think that is an area where that's the kind of area where we would look through the Scott seed funding initiatives, for example, to try to target to grow an area like that. And so we welcome engagement in these frontier areas, even as we double down on the industrial sector.
Good. I apologize, Valerie. I was just going to say that leads us to our next question, which is about sharing a little bit more about the founding partners. So the person who asked the question said, could you share more details about the call for founding industry partners and what you're hoping to get from the relationship, such as funding, challenge problems, expertise?
Great, sure. Yeah, I can take that, and then Daniel perhaps can follow up. The call for founding partners is right now a relatively focused call, and so we certainly welcome companies that would like to self-nominate, but we really want leaders in the areas of energy efficiency, industrial heat decarbonization, building energy management, iron and steel, cement and chemicals. And we want to create a balanced group. So, not just representing one sector or one set of voices. We really want a group that says, I want to be with a set of like-minded peers. Maybe it covers parts of a single supply chain, like the automotive industry, along with steel makers, because they're, on the supply and demand sides of the same equation, to really try to say, how are we going to incentivize, how are we going to share the cost of bringing some of these new technologies into fruition, to have these kind of in-depth, very candid dialogues. And we hope that the industry partners will bring us challenge problems from their settings. I think one of the ways that we've focused, one of our first challenge problems, is really around decarbonizing the steel supply chain, iron and steel supply chain. This is a focused, very, moonshot-like problem. And so this is something that we have decided is a good focus also for a dialogue that the Scott Institute is going to support in the next year or so, to bring together all these, various players. We'll have a group of founding sponsors, and then we'll have a broader group of companies that are engaged where there is no funding asked. For the founding sponsors, we do have I would say, by university, the leading universities in this area, it's a sort of on par funding ask that is really would sustain the initiative with pre-commercial funding for the first 2 to 5 years, but also provide that kind of access to, problem-solving capabilities, student talent, future hires. That sort of, we want to develop that type of long-term relationship with these companies as well. So we're looking ideally for, 3 to 5 dedicated leaders in the decarbonization space, and initially focused on industry.
Yeah, and it's really about, that was perfect, Valerie, and it's really about bringing together these eager researchers with these areas of expertise and connecting them with companies that actually have products, they're putting stuff out there, that are have products, they have services, they have software, they have who knows what, excuse me, but they've made these commitments and they need to figure out how to get there and how to actually get there. And professors are traditionally, measured on the number of papers they publish, and in many other ways as well. But, the research doesn't matter unless it's actually translated out into the real world. So what we're looking for are companies that need the expertise that we share, but we also need kind of the company side expertise to figure out what are the problems, what are the gaps that exist in your plan towards decarbonizing. Because if we don't have that perspective, we're just, doing our own thing and in our own echo chamber, and we don't really know if we're doing and going in the right direction. So that's kind of broadly the motivation behind it.
Very good. And we've got a related question that's come in. In addition to how you've elaborated on the company involvement, the College of Engineering community is very large, and it's made up of, companies and alumni and parents of current students and a variety of friends of ours. So how can this extended engineering community and others who are interested in this type of work help with this initiative?
This is a fantastic question. I think, there are going to be a number of ways to get involved. The very first is, if you're located in or near Pittsburgh, or you're visiting Pittsburgh, see if there's going to be a Decarb at CMU seminar going on during the week that you're here, or that you could, these our email lists and our talks will be open to the alumni community. We also are going to have a working paper series that goes out. We always welcome alumni interest and engagement. If there are members of the broader CMU community who would like to do a remote internship over the summer, I think we can definitely be creative and sort of thinking about ways of getting connected with alumni. In particular, I think there's so much knowledge and connections that alumni can bring to help us, for example, reach out to steel producers in mainland China, or we wanted to work, or in India, and is another example where we're just sort of developing a new leg of that international partnership that would involve India. We have the new campus in Rwanda. I think there are going to be lots of opportunities to work in some of the less developed country settings on these issues as there become questions about where the resource is going to come from for decarbonization, and how is industry in Africa going to evolve? Will it be able to afford to use some of these clean and sustainable technologies, and sort of what types of policy arrangements would enable that? So I think we're going to have these types of conversations, and would very much welcome. We could actually create an alumni email list, and we could, have that be an important way that we engage with you.
Very good, thank you. This has been such a great conversation, and I thank everyone who's been submitting questions to the group, and thanks to Daniel and Valerie for answering them. We only have time for one more question though. Unfortunately, we're not going to get to them all. So last question is it possible to reverse climate change, reducing carbon emissions sufficiently without sacrificing lifestyle choices like reducing AC usage, switching to public transportation, so on and so forth? And if yes, how? And if no, what are the tools to encourage or enforce action?
So I think, the CO2 that we're emitting now is going to stay in the atmosphere for a very long time. Reversing the climate change that we've already locked in is something people do sometimes talk about. There's a suite of technologies associated with that. That isn't really, it's not in scope with this initiative, but it is part of the broader conversation and interest among, particularly, I think, the engineering and public policy faculty, because of some of the ethical issues around that. Now, if I take what you've asked us to say, mitigate climate change or stabilize climate change, or stabilize temperatures at 1.5 or 2 degrees Celsius above pre-industrial levels by the end of the century, we have a very, very small window within which we can do that. And every projection, they disagree in the details, but every projection does have some role for carbon capture and sequestration. There is some, it could be a very small role for very specific uses, could be a much larger role. Renewable energy and to some extent also nuclear energy, hydro, are expected to expand. Solutions for storage, solutions in transportation. I think these deployments can happen without dramatically changing our lifestyle, but energy efficiency will be critical. We just won't, ideally you have passive energy efficiency solutions, and that's where this, I think a lot of the AI and automation and building energy management going on at CMU can really play a role. So I think our going in assumption is that we want people to be able to lead their lives in a way that, where they have a broad range of options to pursue the goals that they have defined. And we hope over time, maybe climate change becomes more internalized in those decisions. But at the same time, we have solutions. We just need to deploy them fast. And that's what we're about.
Well, Valerie, Daniel, thank you both very much for such an engaging session. I've learned a lot, and I hope every one of us who has attended this as well. So a big thank you to you both. I'd also like to thank all the audience members for participating today and submitting such great questions. I hope you'll be able to join us at one of our future faculty insights. So keep an eye on your email for invitations for the next upcoming Faculty Insights program. And you'll also receive in your email a link to the recording of this session. So in case you want to go back and listen to something that we've talked about today again, or share it with friends or colleagues, feel free to do so. So thank you again, everyone, to both of our panelists and to all of our attendees. Have a wonderful afternoon, everyone. Bye.